Alright, welcome back. This is the start of chapter 1, which as we discussed in the introduction video, in case you watch it, it was chapter 1 will be network fundamentals. Okay, we'll start with a brief introduction about networks. After that, we will go deep into every topic that Cisco announced in their new course, and we will discuss the topics. Okay, firstly, what is a network, which is also called computer networks? It is two or more devices needs to share information or are already sharing information between them or between each other. What we mean, in any scenario or in any case where there is more than one computer, a PC, that is able to share information with another computer, no matter how the connection is established between them. Just this case, this scenario of having two or more computers are able to talk to each other and sharing information between them, this is called a network. Okay, to do that, they will need a common media between them to share those information. This might be physical cables media that we are meaning by this, or a wireless media. We will talk more about these medias, how to do them, how to establish them, how to establish any network. Network types, or also called network sizes, because the network type depends mostly on the size of this network and how much devices are inside it. First of all, what is called local area networks, and we can shortcut this saying LANs. We will hear LANs everywhere from now on. Okay, the LANs, which are some users, I have forgot the S here, I'm sorry, some users in the same room or in the same department connected together using a switch device. Now, what is a switch? That is something we will talk about later. It is a networking device. This switch, we will talk about this more later. Okay, but firstly, the first term or the first sentence is that some users connected together, but geographically they are in the same room or in the same department inside the company. This is called a LAN. Or some users in different room or departments connected together using a router and some switches. Now, this is another networking term, which is also a device, just like a switch, and we will talk briefly and in detail about switch and router in the upcoming slides. Okay, so right now the first type of networks, which is one of two, it is the LAN, because so you can indicate that LANs have small sizes. Okay, not that big much of size, not that big geographical spot it's covering. It's only about few users, few computers to connect together using switch, I'm sorry, or using a router, a single router and some switches. We will see this in details. The other type of networks, which is called wide area networks, and it is WANs. Okay, this will be rarely to be used with an associate engineer, which is some users connected together globally through the internet. This is not about a switch device we've mentioned before that is in the corner of the room having some cables to have some 4, 8, even 16 PC computer connected together. No, this is about connected together globally through the internet. Okay, service providers will be needed because this media, this common media that is helping these users to be connected through WANs will be the service providers. Service providers are large companies that do connect multiple users, multiple customers and small companies together through the internet, and might be also connect them together locally and give them a feed from the internet. Okay, second point here, a group of devices, which is router, switches, other devices will be needed. Before we said that to establish a single LAN, local area network, one switch will be enough. Maximum one router and few switches will be enough. Okay, in WANs we will need a group, a lot of routers and switches, sorry, and all of them are in different locations, but they talk to each other. Okay, and that is how to form a wide area network, which is WAN, of course, with the help of the service provider. Okay, now the next slide will be network components. That is something that Cisco has listed as its topic. Network components are what are the components or devices that could be seen in a network and could be used inside a network. So what is network components? What is network consist of? First of all, the first device and one of the most important devices in a network, it is routers. Allow me to delete the notes of the previous screen. First device is a router. These are routers in real life. How do they look? Routers can start from this small size, which, for your extra information, it has the size of one rack unit. Globally, it's called the RU. Okay, it has the size of a single rack unit. Okay, anyway, and it can be increased for 2 rack units, 4, 6, and up to multiple sizes, maybe half a rack. And the term rack, we will discuss it later when we talk about data centers and racks. Routers, the first device, which is, this is how they look in life, and this is how Cisco introduced to you an icon of a rack. This is an indicator that there is a rack, that this is a rack. So we will not draw this in our blueprints, in our upcoming plans, maps, topologies, because there is nothing called a plan or a map in network. It calls topology. Okay, this is not the way that we are planning to draw a router in our topologies. We will draw it this way because this is much easier. You can just draw it this way. Maybe this way can be enough. Okay, just a circle with some arrows. We will talk now about the function of routers. Routers are network devices that connect different network domains. The term network domain, I mean networks, just single separated networks from each other, can be connected using the router. Okay, and routes, I mean, if you are listening to this the first time, I mean by routes, directs the IP packet. We will study IPs, the IP packets to its correct destination. So routers do connect to various networks, and when one network speaks and try to reach other networks, this is the mission of, or this is the responsibility of a router to receive this information from a single network and deliver it to the distant network. Might be only to these 2 or to these 3 networks, might be to all of them, might be to a single network trying to talk to another single network. This is the responsibility of a router. Each interface in a router is, as we talked, is a single separated network. So each interface of these interfaces, as you can see, if the screen was clear to you, this router device have here like 8 ports, might be new term to you, or 8 interfaces. We will use both of these terms in our upcoming study. So each single port of these is called either a port, a networking port, a device port, or it's also called interfaces. Mostly we use interfaces because that is how our configuration in the Cisco commands relies on this term, the interfaces, not the ports. Anyway, so the routers are network devices that connect different network domains. Different separated networks are connected together through a router device, and after that the router do direct the information from single network to other. It's the router responsibility. Okay, hope this was clear. Save the wall. Next, another network device, but this one is more simplified, which is called switches. And these are how switches looks like, but don't be confused. Switches don't start the size, they start the same size of the routers exactly. They start from 1 RU up to half a rack or even larger, like this type of switches. Okay, switches are just like routers but different in the symbol. This is the symbol or the icon of a switch. Network devices that connects 2 or more devices. Doesn't connect 2 or more networks, it connects 2 or more devices, and by devices I mean PC, a server, a phone, which is also called an IP phone, okay, a printer, etc. This is the responsibility of a switch, to connect 2 or more devices in only one, in a single network domain. Switches do not have the ability, like routers, to connect more than a network. No, switches do establish only one network around it, around this device, around it, and whatever is connected to the switch, they are all connected under the same single network domain. Under the same single network domain. Okay? So this is the function of the switch. It doesn't redirect, it doesn't route, it doesn't deal with what is called IP packet, just like I used to say in the routers. This is much simpler network device than a router. Okay? But previously what we had is that whenever we are in a single network or in a LAN, because we had just said that one switch is enough to establish an entire local area network. Okay, maybe more than a switch connected to one router are also enough. And when I say more than a switch connected to a single router, I mean that end devices, and the term end devices I mean PCs, printers, servers, etc. These devices that the human or the person use them directly and cooperate directly with them because they understand the human language. Okay. Whenever we have a router, routers do not connect directly to end devices for a reason that I will mention later. Okay, routers do connect to switches. Switches are the devices that connects to end devices, PCs. Why is this? It's not forbidden, it's allowed, it will function normally. There is no problem with connecting a PC to a router, and we will do so in our labs, in our practical parts in the course. You will see a PC, a computer connected directly to a router. In real life, you will not see this. I doubt it, because there is something which is one of the main differences between routers and switches, and you might be asked on this. It's called the port density. This is very important. Port density is the amount of ports, or we have just said a few minutes ago, it's not it's not called ports only, it's called ports or interfaces. Port density is something very important in comparison between routers and switches. Port density is the amount of ports or interfaces in the single device. How much ports or interfaces does this device have and offer to us to use? Because as you can see, this switch has 2 lines of ports. Each one, if you count these black ports, have 48 ports per line, and you can see that it has 2 lines. So these are a minimum of 96 ports in a single switch, and this is one of the smallest sizes of switches. These others are much larger, and there is another type, which is the first type and the main type of switches, which comes in a single rack unit, just like I have mentioned. Rack switches do start from 8 ports up to 48 ports in the size of a single rack unit. But you can see from 8 minimum, which is rarely, you might start with 16, 24 is the most used, up to 48 port in a single switch. That means you can have a LAN, a local area network, inside your department and have 48 PCs connected to a single switch, or 40 PCs with 4 printers and 4 servers, and also maybe an IP phones. You can simultaneous this or can replace this as you would like. Okay, all of them are connected together by using only one switch. That will be enough. It will be a network. They all 48 devices can talk to each other using a single switch. Routers do not come with 48 devices. Ports, I'm sorry. Routers do not come with 48 ports. Routers have weak or less few, oh, I'm sorry if we can say it's much lesser in port density. Routers do come compared to switches in much lesser port density, because standard of routers we will see in our study start with 2 up to 4 ports. That's few. That is very little number of ports. I said switches start from 8 minimum up to 48. Routers can, depending on the models, but most of Cisco routers start from 2, 4 and maximum of like 8 ports. It's a maximum of 8 ports, whereas in switches it's a minimum of 8 ports. You can see that's the difference. That's why I say you won't notice, or you won't rarely or might never see a router connected directly to a PC because of this, because you have a very little number or few number of ports available in the router. So you don't want to waste them by connecting PCs, because in most cases you have a lot of PCs. So you connect your PCs or your end devices, all of them, to the switch. After that, one last port of the switch should be connected to the router. That is the first benefit and the first difference. Secondly, even if we have a router with only 2 interfaces on it, yes, it will be full functionable and it will be full beneficial. Why? Because on my switch that contains of up to 24 ports, I can connect 20 ports to my network, to my LAN. One of these ports is connected to the router, and since router can connect, or if you remember and if you have recorded note, each interface of a router is a single network. So each interface of these 2 interfaces is a single network. That's first. Second, this router has the ability to route our information to another network. So one of the router ports for me, for my LAN, for my network, and the other can go directly to the, this is an I letter, let me write it again please, to the internet. So you can see that's one router is enough. One router is enough to connect to my switch, and my switch, no matter how many ports it has, it can connect us all inside of it. Once one of the devices needed something from outside the network, it will go to the router, and the router will route it to another switch, or maybe to the internet, or any destination it wants. So that is the main difference between routers and switches. Another thing to mention is routers and switches are different, and each one of them have its own function or its own purpose in the networks. So whenever we needed one of them to do more than its specific jobs, we can't, because router only do few networking functions, switches do other networking functions. What happened is that Cisco and other companies introduced to the world what is called a multi-layer switch. It has another name also, a layer 3 switch. This is the shortcut of layer. The L is a shortcut of layer. Or it's called the multi-layer switch, or a layer 3 switch, and shortcut is the MLS. What is this? Multi-layer switches is the combination of routers plus switches. This device do entirely what routers and switches do together inside a single device. And for the looking about how does a multi-layer switch look, just like normal switches. It doesn't look like routers, like it looks like a switches. And what is the difference between the looking of a router and switch? We came back here. These are routers and these are switches. If you took a screenshot and you compare them, despite the color, because you can have router and switches in many colors, just assume they both have the same color. But what's the difference between these? This is a device with ports and this is a device with ports. One difference that we have talked about, which is port density, which is the most important thing, port density. So if Cisco or any other vendor introduced a multi-layer switch but looks like a router, means has only 2 or 4 ports, this is no use, because we have done almost nothing. If we have a switch, a multi-layer switch, just a combination of router or switch, but has only 4 ports, this has nothing to do. Okay, this is not really that beneficial. Multi-layer switches therefore introduced looking like a normal switch. This is also have another name in the market, which is called, since we have used the term layer 3 switch here, it's called layer 2 switch. Okay, and the multi-layer switch is called layer 3 switch. This is how a multi-layer switch icon look like, and this is for the normal ordinary old layer 2 switches. Alright, so after that there is a multi-layer switch. This multi-layer switch has 2 cores. It can function like a router or a switch. It looks like a switch. It has a lot of ports. Now you can imagine one thing, and yes, if you were wondering, it's true. Now multi-layer switches do come with a minimum 8 up to more than 100 ports, and all of them can function as a router. Yes, all of them can function as a router ports. Before you had nothing called a router with 48 ports or a router with more than 100, 200 ports. Okay, because routers were known with their port density as low port density. That was something related to switches only. With multi-layer switches, yes, you can have a switch device looking like a switch, but it can behave whatever you like. You can buy or you can have a multi-layer switch that has about 24 ports, and we can do whatever and distribute it in whatever order we like. We can split it into half. We can make the first 12 ports behaving as router ports, and the other 12 ports are behaving like switching ports. Whatever you like, any combination you would like, any matter or order in making use of these ports is available to you. You can do whatever you would like. But the default behavior of a multi-layer switch, when you take it out of the box and you start it from scratch, from zero, it's a new switch that you have just bought. It's a new multi-layer switch that you have just bought from the market. The default behavior of a multi-layer switch would be a switch. Okay, would be a switch, and that is something I don't want to talk a lot about in a single video. But another big difference between routers and switches: in routers, the ports of the routers come, as they called, in the state of shutdown. In switches, they come in the state of what's called no shutdown, which is on and functioning. What I mean, if you have a router and switch out of the box, new devices, and all what you have done is that you powered them on, both of them, and you have plugged a computer cable in the router and in the switch. The switch will detect this computer, the router will not, because routers out of the box have their ports all shut it down. You have to do it by force by yourself to unshut the ports, while switches have all the ports functioning and working properly once you power up the device. This is another main reason another big difference between the routers and the switches. Multi-layer switches do behave like normal switches. They look like switches. They have high port density. Also, the third difference is that, or the third point to mention, is that all their interfaces are up and working, but they behave like switching interfaces. So we have to enable routing for each port of the multi-layer switch. Also, we will have to enable what's called IP routing in the core of a multi-layer switch so that we can make use of the routing functions of switches. These are the two main devices in the networking that we will use mostly in all of our labs. We will talk furthermore about other devices next.